Hello everyone, this is the video demonstration of documentation task. In this task 5.1, we'll understand the importance of documentation in software development. Clear and concise documentation is crucial for the maintainability of software, especially in decoupled and reusable systems like ours. Our main goal to learn how to provide documentation for our backend service using the Open API. This specification allows both humans and computer to discover and understand the capabilities of our service. We'll be using ASP.NET Core and Swashbuckle and for implementing the OpenAPI documentation. But we are not in the task sheet. It is said Swashbuckle, but we are using the Swagger. So yeah, let's start setting up the project. We copy the robot command folder that our previous solution and install the Swagger package using the .NET Add package. Now let's UI of Web API documentation. We'll personalize the UI by changing the theme, substituting the default Swagger logo. Moving on with documentation of our API endpoints, we'll use XML comments in our code to provide auto documentation and means for the developer using our API. So moving on to explaining the file, the first file is mapcontroller.cs. Uh, Firstly, the namespace and class declaration. We start by declaring the namespace and class of a controller. It inherits from controller base and is tagged attributes API controller and route API must to specify the route of handling map request. The get method. The get method is decorated with HTTP get attribute indicating that it handles HTTP get request. It retrieves all map from the data access layer and returns an HTTP 200 OK response with the retrieved maps. Similar to the previous method, get square maps retrieve square maps where the number of columns equals to the number of rows. This method retrieves a map by its unique identifier. It takes an ID parameter from the route, retrieves the map with specified ID, and returns a HTTP for not found response if the map is not found. The add map method handles HTTP post request to add a new map. It takes a map object as input, checks if the new map data is null, sets created and modified dates, inserts the new map into the data access layer, and returns an HTTP 200 created response with the newly added map. This method updates an existing map by its ID. It takes an ID parameter from the root and adds an updated map object as input, retrieves the map updated, sets the modified dates, updates the map in the data access layer, and return the HTTP 204 node content response indicating successful update. In this delete map, when the delete map method handles HTTP delete request to delete a map by its ID, it takes an ID parameter from the root, retrieves the map to delete it from the data access layer. Finally, the check coordinate method checks if the given coordinates are within the boundaries of a map. It takes ID, x, and y parameters from the root. Check if the coordinates are negative, retrieves the map. Check if the coordinates are within the map boundaries and returns an HTTP 200 OK request. Moving on to the next file, that is robot command controller.cs. Here we start by declaring the namespace and class for our controller. It inherits from controller base and is tagged with the attributes API controller to specify the route of handling robot command related request. So the get method is with the HTTP get attribute indicating that it handles the HTTP get request. It retrieves all the bot commands from the data access layer and returns an HTTP 200 OK response with the retrieve commands. This method HTTP get only the move commands for the robot. It also decorated with HTTP GET attribute but has a specific route for move. It filters only move commands for all robot commands and returns them. Then the get robot command by ID method. This method retrieves a robot command by its unique identifier. It takes an ID parameter from the root, retrieves the command with the specified ID, and returns a response is not found. Then the post method request it requests add a new robot command. It takes a robot command object as input. As you can see, check if the new command data is null or if a command with the same name already exists, sets created and modified dates, inserts the new command into the data access layer and returns an appropriate HTTP response. This method updates an existing robot command. It takes an ID parameter from the root and add an update command object as input, retrieves the command to update, check if a command with the same name already exists. Finally, the delete robot command handles HTTP delete request to delete a robot command by its ID. It takes an ID parameter from the root, retrieves the command delete its own data access layer and returns an appropriate HTTP commands. Now moving on to the map data access. In this, we start by declaring the namespace and class for a data access layer. This class contains static methods for interacting with the database to perform crude operations on maps. We define a constant connection string which contains the connection string for our PostgreSQL database. This string specifies the host username, password, and database name. Get all method map. This method retrieves all maps from the database. It opens a connection to the database using an PGSQL connection, execute a select query to fetch all rows from the map table and match the query result to a list of map objects. Update map method. This method updates an existing map in the database. It opens the connection, executes update query with parameters. This method inserts a new map into the database. It opens a connection, executes an insert query with parameters for column, rows, name, description created by and modified date, then executes the command. Now I'm moving on to delete robot command. This method deletes a map from the data. By its ID, it opens a connection, executes a delete query with a parameter for ID, then executes the command. Moving on to robot command data access. Firstly, we start by declaring the namespace and class for our data access layer. This class contains static method for interacting with the database to perform CRUD operation on robot commands. Similar to the map data access class, we have a constant connection string which contains the connection string for our PostgreSQL database. This method now get robot method. This method retrieves all robot commands from the database. It opens a connection to the database, execute a select query to fetch all rows from the robot command table and match the query results to a list of robot command objects. Update robot command method. This method updates an existing robot command in the database. It opens a connection, executes an update query with parameters for name, description, risk, mode, command, modified date and ID, and then executes the command. Nextly, the insert robot command method. This method inserts a new robot command into the database. It opens a connection, executes an insert query with parameters for name, description, is move command, created data, and modified data, and then executes the command. Nextly, the delete robot command method. This method deletes a robot command from the database by its ID. It opens a connection, executes a delete query with the parameter for the ID, and then executes the command. Moving on to the next file, that is map.cs. Firstly, we start declaring the namespace and define the map class. For the properties, ID represents the unique identifier for the map. For the columns, represent the number of columns in the map. For rows, represent the number of rows in the map. For the name, represent the name of the map. Description represent an optional description of the map. Created data represent the data and time when the map was created. Modified data represent the data and time when the map was last modified. For the constructor initialize the map object with the provided values for ID, column, rows, name, description, created data, and modified data. Now for the next file, that is program.cs. In this we can integrate our Swagger into our application. Firstly, the namespace. We start by importing necessary namespace, system.reflection, and robot control API persistence. Next, we creating the builder. We create a new instance of that application builder using the web application create builder args method. Nextly, we add service to the container using add controllers to the enable MVC controller, add endpoint app explorer to enable endpoint API explorer, and add Swagger gen to configure Swagger generation. Within add Swagger gen, we define the Swagger document with version information, title, description, contact details. We also include XML contents from assembly for better documentation. We build the application using builder build. Nextly, configure pipeline. Inside the pipeline configuration, we check if the environment is development and use the developer exception page if it is. We then enable servicing static files such as CSS file for our Swagger UI. We enable Swagger and Swagger UI using api.useswagger and api app.useswagger UI. We also inject a custom style sheet to style the Swagger UI. HTTPS redirection and authorization middleware are added. Finally, the map controllers and run the application using app.mapcontrollers and app.run. For the remote command.cs file, we firstly defining the robot controller API namespace and declare the robot command class within it. The robot command class has the following properties: ID, name, description, is move command, created data, modified data, as also I explained previously in the map.cs. They have the same properties. For the constructor, class defines a constructor that analyzes the properties of the robot command object. It takes the following parameter: ID, name, is move command, created data, modified data, and description. Thank you.
This is the output of 5.1p documentation. So I'm running it by putting the command.net run. Here comes the local host. I'll copy it and paste it in the Swagger UI. As you can see, here are the all commands: get, post, get. I'll try it out, execute, and here comes the response body: ID4, ID6, ID17, and ID5. After posting it, It is coming id 0 column 0. I'll edit it by removing id created data and modified data, because id will is synchronized and it will come in number. As you can see, it is updated in the new id. Now I'll get the square. This is the square one with column and rows are same. Now I'll retrieve a unique id by putting a id number, that is 6, and execute. Here comes the 6th id. Now I'll update an existing map by putting the id number 6 and delete the existing map. Now it is deleted. Now I'll get the given coordinates. I'll give the id and xy coordinate. True. Here comes true because the coordinate falls in the, and we'll do the same for the robot commands. Thank you.